Hi, this problem was requested to me by someone from the AOPS community. It's a mock AMC 10, not an official AMC 10. It was made by AOPS user fidgetboss_4000 in his 2019 mock AMC 10C, problem number 23. It says Bernardo has an infinite amount of red, blue, orange, pink, yellow, purple, and black, that's 7 colors if you're counting, blocks. He puts them in the 2x2019 grid. It probably should say a 2x2019 grid because they don't give you a picture, such that adjacent blocks are of different colors. What is the hundreds digit of the number of ways he can put the blocks in? Okay, so don't worry about the hundreds digit part of it. Worry about finding the number of ways he can put the blocks in. Find that first, then think of a strategy to handle the hundreds digit aspect. So for starters, let's make a little grid that goes a column of 2 and then keeps going to the right. We don't need to really go that far. Let's think about how many choices he has for the first block. 7 choices. Then the block right underneath it will have 6 choices. So for the first column, there's 7 times 6 is 42 ways for him to set it up. The second column is a little more complex because there's actually 2 scenarios we should consider. The first scenario will be when, let's call the colors A, B, C, D through whatever 7 letters are, and say that he chose A for this block and B for this block. Then under subcase 1, he can do, hold on, A, B. He can do the same color in the upper block that he chose for this lower block because they're not adjacent. So if he matches this one's color, he will have 6 choices for the bottom block here, giving 6 ways for this subcase to work out. For the second subcase, what if he doesn't use the same color block here, but uses a third color block that doesn't match A or B? Then he will in fact only have 5 choices for the color down below. So the color right here, if he doesn't use A or B, also had 5 choices, and 5 times 5, there are 25 ways for the subcase 2 to work out. Then these 2 are 31 ways to fill in this column. Now, it stands to reason that every column after this, all the way to the end, will have the same 31 ways to be filled out. So we can just simply multiply 31 to the power of how many columns remain, which is 2018. We've gotten about a third or a half of the way through the problem now. We know the number of ways he can do it, but we need the hundreds digit of the number of ways he can do it. So we switch gears to a new tactic. We're going to ignore 42 for right now and just think about this 31 to the 2018. There is a strategy to this that we can use, and that's that we can use a combination of binomial theorem, binomial expansion, and modular arithmetic. So in binomial expansion, you have 2 things to a power. Let's just use 2018. Then this will equal 2018 choose 0, and A to the 2018 power, B to the 0 power, the bottom number, plus 2018 choose 1, A to the 2017, which is the difference in these 2 numbers, B to the first, plus it'll be 2018 choose 2, A to the 2016, B to the second, and so on. Now, we're not going to actually have to worry about anything past this point for a reason, and we'll show that in a second. We can take 31 and separate it into 2 parts. Let's make that 1 plus 30 to the 2018. Then in this case, this will be equal to 2018 choose 0 times 1 to the 2018 plus 2018 choose 1 times 1 to the 2017, 30 to the first, plus 2018 choose 2 times 1 to the 2016, 30 to the second power. Now, after this point, we actually are not going to care what happens. I'm not even going to write the ending on there. Even though it's not infinite, just ignore that. The reason we don't care is because the next term and every term after it is going to have 30 to the third. And 30 to the third is 27 with 3 zeros, which would be 27,000. That means it'll be a multiple of something in the thousands for every other term. And the good thing about that is we don't care about anything in the thousands because we're looking for the hundreds digit, and all the rest of the terms are going to contribute a 0 in the hundreds digit column. So we just disregard them and consider this as mod 1000. And it'll be congruent then in that case. So then we progress. 2018 choose 0 is going to be 1 times 1 is still 1. 2018 choose 1 is 2018 times 30. The 1 we're going to disregard for now on. 2018 choose 2. You should know the shortcut that n choose 2 is n times n minus 1 over 2. Then in that case, this becomes 2018 times 2017 over 2 times 30 squared, which is 900. And this again is mod 1000. Technically, when you're doing your test, it's not for school, right? So your work doesn't really matter. You don't have to keep writing mod 1000. In fact, I'll probably drop it at some point in this problem because no one's grading your work. They're just grading your answer. So feel free to take shortcuts you're not allowed to take in school. Okay, so then this will be equal to 1 or congruent to, again, we don't care about the 2000 here because it's not in the hundreds digit. The hundreds digit is never affected by the thousands digit and on. So we can just simply multiply 18 times 30 and we will get 3 times 18 is 54 with a 0, 540. And we can mod this out, mod 1000, and disregard whatever that 2 contributes to the problem. Okay, then 2 goes into here 1,009 times. Once again, we can just mod out these terms individually. So if I multiply these 2, I only have to be concerned with 9 times 17, which is 9 times 10 is 90, plus 63 is 153, still times 900. Then what? From here we will continue. We get 1 plus 540 plus 9 times 153 is going to be 900, and 450 is 1350, and 27 is 1377. And then add the 2 zeros back on. Okay, so then from here we can disregard the 137 and just mod out to the 700 because it's all that's going to contribute. So we have 700 plus 540 is 1240 plus 1 is 1241, which is also congruent to 241, again, mod 1000. All right, so now that we're down to this value, mod 1000, we can simply multiply it with the 42, and whatever hundreds digit we get is the equivalent hundreds digit of the original expression. So we multiply now 42 times 241. 2 times 241 is 482. Throw a 0 on, get 4, 16, and 1, and 9. Again, we don't care what happens over here. 2, 12, 1, 11, 1, but we don't care. We care about this digit right here, which is a 1, and that makes the answer choice B. Hope this helps.